Okay, hello everyone. In a new video, in this one we are going to solve an exercise related to electricity in the chapters of AC voltage and the voltage of the mains. This exercise was a previous one in the brevet exams in 2002, first session, first exercise. The title of this exercise is voltage of the mains. The adjacent graph, they mentioned the graph, then now we can use it, represent the variation as a function of time, the voltage across the terminals of a generator. So here the x-axis is labeled by the time t, whereas the y-axis is labeled by the voltage u. This voltage u is being delivered across the terminals of a generator. So take square root of 2 is equal to 1.4. Now the trick in solving such type of exercises is to determine the values of x and y, as well as the vertical sensitivity and the horizontal sensitivity. So here x represents the number of divisions between two consecutive peaks. So let's choose these two peaks, and the number of divisions in this case is given by 1, 2, 3, 4. Now as for y, it is the number of divisions from the center to the maximum point reached by this waveform. So let's choose the point A. Now 1, 2, 3, 4. Now y also correspond to 4 divisions. Now the vertical sensitivity, or the scale along the y-axis, is given by 77 volts per division. So let me write here that SV is equal to 77 volts per division, whereas the horizontal sensitivity, which is the scale along the x-axis, is given by 5 milliseconds per division. Knowing that millisecond per division is not or millisecond is not the assigned unit of time, in order to convert from milliseconds to second, we divide by 1000, then 5 divided by 1000, then the horizontal sensitivity, or the horizontal scale, is given by 0.005 seconds. Now part A of number 1. Is the voltage represented by the graph direct DC, triangular, or alternating sinusoidal? So as we can see that this voltage varies with time, so it is alternating, and the shape is given by sinusoidal, so it is alternating sinusoidal. Here no need to justify. Now in part B, specify a point on the graph that may be used to determine the maximum value UM of the voltage. So here specify means that we need to state with the justification, but here the justification doesn't apply. So we need to choose a point which allows us to determine the maximum voltage. And this point, as we have done here when we have determined the value of y, is the point A, because it's from the center to the maximum point reached by the wave. So the point is given by A, and they are telling me to calculate UM, which is given by UM is equal to SV multiplied by Y, which is the number of divisions from the center multiplied by the vertical scale. Now the value of SV is given by 77, and the value of Y is given by 4. Now plugging this on the calculator, it will give me 308. Since everything in the SI, both SV and Y, so the value of UM will be in the SI, which is volts. Then UM is equal to 308 volts. Now in part C, name a couple of points on the graph that allows us to calculate the period T of that voltage. Now we know that the period T is related to the value of X, because we know that the period is equal to SH multiplied by X. So the couple of points will be A and P. So the points are given by now they are telling me to calculate the period, which is given by SH multiplied by X. The value of SH is given by 0.005. And the value of X is given by 4. Plugging this on the calculator, it will give me 0.02 seconds. Then the period is given by 0.02 seconds. And in the same part, they are telling me to deduce the frequency f. And deduce means that we need to use the part just previously before. And we know that the frequency and the period are related via the following formula. Now 1 divided by 0.02. Plugging this on the calculator, it will give me 50. Since the period is in the SI, so f will be in the SI, which is hertz. Then the frequency is given by 50 hertz. So here, f is equal to 50 hertz. And here it is alternating sinusoidal. Part D, a voltmeter in the AC mode connected across the generator indicates a value U. So here, because we are measuring the voltage across a generator which is alternating sinusoidal, we have two voltages and they are given by UM or U effective. They are telling me what does U represent relative to the voltage across the generator. So for sure U effective, because it is the one that makes the effect. So the voltmeter doesn't measure the maximum voltage. They are telling me to calculate U, and we know that. So first, let's justify what does U represent relative to the voltage across the generator. Let's say a voltmeter in the AC mode measures the effective voltage. Then in this case, then U represents the effective voltage. And they are telling me to calculate U, knowing that U maximum is given by 308 volts. So U is equal to UM divided by square root of 2. The value of UM is given by 308. And the value of square root of 2 is given by 1.4. Now plugging this on the calculator, it will give me 220. Since UM is in volts, so the value of U will be in volts also. Then the value of U is equal to 220 volts. Now finally, number 2. The voltage across a wall outlet in your house is identical to that represented by the graph Y. And now, because we have determined the properties of the voltage delivered through this generator, which is represented by the graph, and the properties of this voltage is given by it is alternating sinusoidal, and the frequency is 50 hertz, and the effective voltage is 220 volts. And knowing that the wall outlet delivers a voltage having the same properties, for this reason both voltages are identical. So let's say, since the wall outlet let's say supplies a voltage of type alternating sinusoidal of effective voltage and frequency 50 hertz, then both voltages are identical since they have same properties. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.